All right, so we're going to start with question number 2 from the review. Question 2 starts with these words, find TS. Does anybody remember what it means when you have two capital letters side by side like this with nothing over the top of it? What am I asking you to find? The midpoint. Not the midpoint, not here. I want the midpoint over here, but just when it says find TS, when you have two capital letters. Length or distance, yes. So one of the things I want to warn you about is one of the things that we were responsible for learning in this module is what the different notations mean. So one of the things that we should have learned in this module is what it means when we have those two capital letters side by side with nothing over the top. So if it says find and two capital letters, you know what to do. Tomorrow on the test, I guarantee there will be a problem that says find and then has two capital letters. You have to know what that means. I will not be able to tell you that tomorrow because one of the things that I'm testing is, do you know what the notation means? So please make sure you know what it means when there is no dash, no arrows over the top. So we're going to find the length of segment TS, so TS, and then a big long square root sign. I will give you the formula for distance on the test. I will give you the distance formula and the midpoint formula. Please refer back to those formulas to make sure that you put the pluses and the minuses in the right spots. One of the things that I noticed, bless you. Yes, you may. One of the things that I noticed as I was grading the skills checks yesterday is that sometimes we stopped writing down the square root symbol. And so then we forgot to take the square root at the end, and we ended up with a number that was much, much larger than the actual answer. You okay, Marcus? You all right? Do you want to go to the nurse? You already went to the nurse? All right. If you want to move towards the back of the room, you're welcome to do that. All right. With our distance formula, we do x2 minus x1. So I'm going to let point T be my x1, y1. And I'm going to let point S be my x2, y2. y2 minus y1 would be negative 5 minus 1. Close the parentheses and square it. Plus, and then in our other set of parentheses, we do y2 minus y1. So that's going to be 16 minus, what is our y2? What is our y2? Negative 4. Negative 4. Close the parentheses and square it. All right. What happens when we minus a negative? Becomes a positive. All right, so we have TS equals big square root sign. I have negative 5 minus 1 squared plus, and then here we have 16 plus 4 squared. What is negative 5 minus 1? Negative 6. So I have negative 6 squared plus, what is 16 plus 4? 16 plus 4, 20. 20 squared. What type of a number do you get when you square something? Positive. Please make sure you're taking the time to put the parentheses in the calculator before you hit that squared button. Otherwise, it will give you a negative answer, and that will be wrong. What is negative 6 squared? 36. So I have 36 plus 20 squared is 400. So then we add those two together, we get 436 square root of 436. Please, 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 please make sure that you are still writing down the square root sign. Every single step, write down the square root sign. Because when we forget to write it down, we forget to do it. Then we pop this into our calculators. And when you hit enter, after you put it into the calculator, if it doesn't give you a decimal, what button do you push? The arrow is right above the enter key. So you're going to do second x squared 436, enter, and then the arrows. This comes out to be 20.881. 20.881. All right. The question goes on to say, and the midpoint. So we found the length. Now we're going to find the midpoint. Our midpoint formula, which I will give you on the test, is x1 plus x2 over 2, y1 plus y2 over 2. Close my parentheses. Now we're going to take and substitute in. My x1 is 1, so 1 plus my x2 is -5, so I have 1 plus -5 over 2, comma. And then my other fraction, we have y1, which is -4, plus y2, which is 16, over 2. Close the parentheses. What is 1 plus -5? -4 over 2. What is -4 over 2? -2. So -2 is the x part of the ordered pair for the midpoint. Let's go over and do the y part now. What is -4 plus 16? 12 over 2. What is 12 over 2? 6. So our midpoint is at -2, 6. What else would you guys like to see? Yes. Absolutely, we can do that.
I feel hot. So, is it hot out in here?
Not particularly.
I didn't even went to gym today.
There you are. All right. What other problems would you guys like to see me work through from the review? What other problems would you guys like to see me do from the review? What else would you guys like to see? I'll work through anything that you want to see. Yes. 23, absolutely. Number 23 actually has a lot of similarities with the problem that we just did, because we're going to find length and we're going to find midpoint again. Directions start off with graph and label segment GO. And then it gives us points G and O. G is at -4, 3. So from the origin, I go left 4 and up 3 and plot my point. Please don't forget to label it. It's not enough to just put the dot. You have to label it as well. And then O is at 6, -5. 6, -5. From the origin, we go right 6 and down 5. So right here is point O. And then you grab a straight edge And you connect those two dots. That is the first thing that they asked you to do right here. The dash over top of GO means that you have to connect them. If you don't connect them, it is points off because you didn't do what it asked. And then it says find the midpoint of segment GO and label it point H. So we have our midpoint formula. Midpoint is equal to parentheses x1 plus x2 over 2, comma, y1 plus y2 over 2, close parentheses. We're going to be calling our midpoint H, so I'm going to have H equals, and then parentheses. Let's let point G be our x1, y1, and point O be our x2, y2. So now when we take and substitute in, when we do x1 plus x2, that would be negative 4 plus our x2, which is 6, over 2. And then y1 plus y2 is 3 plus negative 5 over 2. What is negative 4 plus 6? 2. So I have 2 over 2. What is 3 plus negative 5? Close. Negative 2 over 2. What is 2 over 2? 1. And negative 2 over 2? Negative 1. Here's our midpoint H. We're going to go add that to the graph because it said label it point H. So over on the graph, 1, negative 1 is right here. And we're going to label that as point H. Then find GH. What's it mean again when there's nothing on top? Find the distance or the length. Find the distance or the length. Distance and length get used interchangeably. And we're going to find the distance or the length from where to where. What are those two letters? G and H. Well, point G was one of my endpoints. And we called that one x1, y1. Are you guys okay if we leave that as x1, y1 for this? Would I use O for the other point? No, it says find GH, so I have to let H be my x2, y2 for distance. So from G to H equals big square root sign. First set of parentheses, we have x2 minus x1, so that is 1 minus negative 4. Close my parentheses and square it. Plus, new set of parentheses, y2, so negative 1 minus y1, which is 3. Close my parentheses and square it. What happens in the first set of parentheses where you subtract a negative like this? Becomes a positive, yes. So from G to H, we have this big long square root sign. I have 1 plus 4 squared plus negative 1 minus 3 squared. What is 1 plus 4? What is 1 plus 4? 5. So I have 5 squared plus, what is negative 1 minus 3? Negative 4. So negative 4 squared. What types of numbers do we get when we square things? Positive. What is 5 squared? 25. Plus, what is negative 4 squared? Be careful. 16. Then we add those two together. We get 41 underneath our radical. And then we have to put that into our calculator. Don't forget to be writing down the square root signs over all the tops of these so that we don't forget to do it at the end. From G to H, when we pop this in the calculator, that's 6.403. 6.403. All right. What else would you guys like to see? Which one? Number 25? Absolutely. Let's flip the page. Number 25. For the picture in number 24, write 4 true equations using the betweenness of points, the segment addition postulate. So we are supposed to write 4 true things here using this picture up on top. Well, I see this little segment and this little segment side by side, and together they make this bigger segment. So RS plus ST equals what? RT. I could look at ST still, this little segment, and TW, the one right next to it, and together that would make this segment. So ST plus TW is equal to what? SW. There's this little segment, 1, this little segment, 2, this little segment, 3. I can put all 3 of those together. RS plus ST plus TW. And what would be the name of the big segment that those 3 smaller ones together make? RW. If I have segment RW and I take away segment RS, so I have the whole thing, but then I take away this part right here. What am I left with? SW. There are 4 true statements that we can make using the betweenness of points, using the segment addition postulate. What else would you guys like to see? Number which one? Number 3, absolutely. Let's go back to the front page and do number 3. The midpoint of CD is negative 3, 9. If the coordinates of D, of point D, is negative 13, 4, what is the coordinate of point C? So the first thing I'm going to do is I'm going to draw a picture here. What should the ends of my segment be called? C and D. I know there's a midpoint on this segment because it said so right here. So right in the center, there's a midpoint. That means this segment is the same size as this segment. And I also know it has the ordered pair negative 3, 9 coming from right here. Then it says the coordinates of point D are negative 13, 4. So over here at D, I'm going to put negative 13, 4. And we are trying to find point C. If I sit here, can you guys see on this side of the room, can you see the board okay still? All right. If I block you at all, if I block your ability to see, please let me know and I'll get up and move. All right. So we're going to use our midpoint formula. Midpoint equals x1 plus x2 over 2, comma, y1 plus y2 over 2. Close my parentheses. The midpoint has to go in for the words midpoint. Midpoint can never go into my fractions in my formula. Midpoint doesn't belong there. That's where the ends go. So negative 3, 9 goes in over here on the left. On the right, we have x1 plus x2 over 2. Let's let our point D be our x1, y1, and the point that we're looking for be our x2, y2. So I would have negative 13 plus x2 over 2, comma, another fraction, 4 plus y2 over 2. Close my parentheses. How many variables are we looking for? 2. We're looking for an x and a y. You're welcome. We're looking for an x and a y. So I need an x equation and I need a y equation. The x equation comes from the x part of the ordered pair for the midpoint and my fraction that has x in it. So I would have negative 3 equals negative 13 plus x2 over 2. The other equation comes from the y part of the midpoint and my y fraction. So I would have 9 equals 4 plus y2 over 2. When you see a fraction, what operation is happening there? Division. We want to get rid of the fraction, so I want to get rid of the division. What operation undoes division? Multiplication. So we're going to multiply by whatever's on the bottom of our fraction. We're multiplying both sides by 2. Cancels out my denominator. So then I have negative 6 equals negative 13 plus x2. I'm going to add 13 to both sides. What is negative 6 plus 13? 7, yes. So 7 is my x2. So this ordered pair that I'm looking for point C, the x part is 7. And then for the y equation, we're going to go through the same process. We're going to multiply both sides by 2 to cancel out that denominator. That gives me 18 equals 4 plus y2. And then I'm going to subtract 4 from both sides. What is 18 minus 4? 14. So I have 14 is equal to y2. So the y part of the ordered pair for point C is 14. All right. So we have 15 minutes left. That's enough time for 2 or 3 more questions, depending on how long they are. What is something else you guys would like to see? Number 27, absolutely. Number 27 is the very, very, very last problem. So back side of the last page. Number 27 down here. Are LP and NR congruent? Now, when I'm on a number line like this, that is an axis. Is it the x-axis or the y-axis that goes back and forth like this? It's the x-axis. I can use any of my formulas that have x's and y's in them. If I'm on a number line, I just don't do the y part. I just ignore it because there is no y-axis. So we're going to do just the x part. However, if I'm wanting to know if things are congruent, I can also just count the hops in between the dots. So from L over to P, I would go 1, 2, 3, 4. That has a distance of 4. NR, here's N, here's R, and we count the hops. 1, 2, 3, 4. Are those two segments the same size? Yes. 4 equals 4. Guys, turn the music off, please. Find LR. Well, L is this one here, and R is this one back here. We can count the hops. 1, 2, 3, 4, 5, 6. So LR equals 6. Find the midpoint of LP. Here I am going to use a formula. Our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Close the parentheses. But because we don't have a y-axis, we're just going to ignore this part of it. We'll just do the x1, x2 part. So what is the number there for L? -3 plus, what is the number for P? 1. And then we're going to put that over 2. What is -3 plus 1? -2 over 2. What is -2 over 2? -1. So our midpoint of LP is -1. What else would you guys like to see? What else would you guys like to see? Number 14, absolutely. Thank you, Marcus. Number 14, name 3 collinear points. Collinear means they're on the same line. LPM would absolutely work. Could you do LPQ? Yep. Could you do these ones right here? G, H, and J? Yes. LPM is the first thing I heard, so let's go ahead and write that down. LPM. There are 2 different lines that you can look at for this. One of them is this line right here. You can pick 3 of those 4 points. It only asks for 3 collinear points, so we picked 3 of them off of that line. Or you can look at this line here, G, H, and J. That would also work. Name the right second plane 2 different ways. So we're looking at this plane right here. Does anybody see a capital letter with no dots next to it? B, right up here at the top. So we can call this plane B. You have to write the word plane. and then a capital B. It said to name it 2 different ways. So we're going to name that same plane another way. I need 3 letters that make a triangle. GMF. We could do GMF. In fact, there's only 3 points that would not work. You can't do GH and J because those you can't make a triangle out of. If they're all on the same line, it will not work. You cannot name the plane if the points are all in a line together. All right, part C. Name 2 points that are non-coplanar with C and E. So I've circled points C and E. That's all on plane A. I want any 2 dots that are not on the same green shaded space as those 2 circled points. F and Q would work. F and Q. We could do point P because that's not on the same plane. We can do any of these circled points. Any 2 of those points would work. Name the line that contains point D. Well, here's point D. What's one name I could give to that line? Line W. You do have to write the word line if you're going to name it with a lowercase cursive letter. Line W. What about if you didn't want to name it line W? What else could you call this? DE. Now, just DE with nothing over the top, does that mean line? What does it mean if there's nothing on top? Distance means the distance, but we want to say the line, so I need a dash with arrows over the top. All right. Part E. I got a little confused by this because if you look right here, there's a Z, and it asks for another name for this line, but there's only 1 point on that line. That's not really going to work. Is there another Z anywhere on the page? Yes, this guy right here. It goes with this line. So we want to name this line right here. Oops. What is one possible name I could give to that line? LP. LP with a dash and arrows over the top. Can you give me another name for the same line? PF. Not PF. I said M. I apologize, I misheard. PM would absolutely work. PM would work. Would LM work? Yes. We could do LM. Could we do LQ? Yeah, we could do LQ. So we could keep going with these names. Don't forget to do the dash with arrows over the top. Last part. Name a line segment on line Y. With a line segment, we do a dash on top. No arrows. Line Y. Got to go looking for this. Here's line Y. What is a segment that is on that line? GH. So GH with a dash over the top. Could you give me another segment that's on that same line? HJ with a dash over the top. What about, could we do GJ? Yep, we could do GJ with a dash over the top. All right, nicely done. I think I have enough time for one more question, but before I take that question, I want to show you guys where the answer key for this entire test review is on Canvas. You guys will be turning this in tomorrow. I do grade it. I grade it for completion, but I post the answer key ahead of time, so there's no reason why you guys should not be able to get this completed. You want to work through it to the best of your ability, and then use the answer key to check your work or to get you started if you get stuck or confused. You start by clicking on modules in Canvas, and then you're going to scroll down to the bottom of module 1 until you see today's day, Thursday, 8/14, module 1 review day 2. You're going to click on that. You're going to scroll down. Now, right here, after school, there will be videos posted for all 4 sections of geometry that I have for the reviews. It can be really, really helpful as you're studying for the test to go in and watch a video from a different class because I went over different questions in each class. But if you scroll all the way down to the very, very, very bottom of the page, and you click here where it says Module 1 Test Review 2005 P, it takes you to all of my work with all of the answers. So you guys have access to the entire answer key. All right. That's enough time for one short question. What else would you guys like to see? Number 12? Absolutely. Given the picture to the right, answer the following. What is the name of point K? Oh, this is a great question. Oh, thank you for saying something. Do you guys see these little marks right here? What do those mean? Congruence. So it's saying that JK and KL are the same size. And K is the point right in between them, exactly in the middle. So what would we call this? Midpoint. So that's what we're looking for on that line, midpoint. All right, now they want me to write down the congruence. What are the 2 segments that are congruent? JK with a dash over the top and KL with a dash over the top. Then it says find the length of JL. Well, I start off with knowing that JK is congruent to KL, which means the measurement or the length of JK is equal to the measurement or the length of KL. And then we're going to substitute in. How big is JK? 2 times x plus 6 equals, what goes in for KL? 3x plus 8. All right. We're going to take the 2 and distribute it inside the parentheses. So I have 2x plus 12 equals 3x plus 8. Then we're going to get our x's on the same side. So I'm going to minus 2x from both sides. That gives me 12 equals 1x, or just x, plus 8. And then we minus 8 from both sides. What is 12 minus 8? 4. So x is 4, but they wanted the length of JL. Well, JL is JK plus KL put together. That gives me JL. JK is 2 times x plus 6. KL is 3x plus 8. Those 2 put together give me JL. What can I put in for x? 4. So I have 2 times 4 plus 6 plus 3 times 4 plus 8. What is 4 plus 6? 10. What is 2 times 10? 20. What is 3 times 4? 12 plus 8. What is 12 plus 8? 20. And 20 plus 20 gives me? So 40 is equal to JL. All right. Please don't forget you will be turning in your test review tomorrow when you come in to take the test. Have a great rest of your day, guys. I'll see you then.